Hi children, namaste. So let us start today the new topic, that is sum of first n terms of an AP. So before I start, let me recall you what we learned till now. So we learned general form of an AP, the meaning of arithmetic progression and the use or application of arithmetic progression in our daily life, and we completed exercise 5.1 and 5.2. Before I start 5.3, I need one more formula, that is sum of first n terms of AP. So let me ask one question children. Here I have written one AP. AP is 2, 4, 6, 8, 10, 12 and 14. If I ask you, can you add 100 numbers from the first of this AP? Can you give the answer immediately? No, it's not possible even with me also. But a mathematician called Gauss, when he was 10 years old, so his teacher asked him, what is the sum of first 100 natural numbers? So as you know, natural number starts from 1. 100 natural numbers, he immediately told within a fraction of seconds that his answer is 5050. Imagine that how brilliant he was in his 10 years old. So that's why he called as Prince of Mathematicians, and is considered one of the 3 greatest mathematicians of all time, along with Archimedes and Newton. So now let me start how and what trick he might have used in that age to answer so fast. So he used he has written S equal to 1 plus 2 plus 3 plus etc. 100, because we want 100 natural numbers. And then he reversed this, that is S equals to 100 plus 99 plus 98 so on 1. And he added these two corresponding terms, S plus S, that is 2S, 1 correspond, that is 100, 1 plus 100, 101, 2 plus 99, 101, 3 plus 98, 101 and so on, 100 plus 1, 101. So can you, this is addition. As you know that repeated addition is nothing but multiplication. So can you multiply this? Can you simplify? Yes. This 101 is repeating how many times? 100 times. So you can see 100 times. Therefore 2S equals to 100 into 101, that is S equals to 100 into 101 divided by 2, he got S equals to 5050. So this is the trick he used to answer in that age. The same thing, so he applied to introduce the formula for sum of n terms of AP. Now I'll explain you how you got the sum of n terms of AP. Means why we use this formula? We use to add any number of terms in a given AP. So how to? This is a derivation of this formula. S equals to a plus d and so on, it is a plus n minus 1 into d. So as you reverse there, you can reverse here also, a plus n minus 1 into d. So this is one term children, and what is the immediate term of this when you reverse? That is n minus 1 becomes n minus 2. So that is a plus n minus 2 into d and so on. So this a comes at last, that is a here. And now you add S plus S becomes 2S, and a here first term is a and here first term is a plus n minus 1 into d. Add these two, you get 2a plus n minus 1 into d. Similarly here second term is a plus d and here second term is a plus n minus 1 into d. Add these two, you get again 2a plus n minus 1 into d. And last, add here a plus n minus 1 into d plus a, that is a plus a, 2a. 2a plus n minus 1 into d. So how many times we got here 2a plus n minus 1 into d? N times. Yes, why? Because we have taken n terms. So we got n into 2a plus n minus 1 into d. Bring 2 on RHS, it becomes n by 2. So at last, what is the formula to use sum of n terms? Sn equals to n by 2 into 2a plus n minus 1 into d. Don't get confused children, there in nth term we have a plus n minus 1, but here you have 2a plus n minus 1 into d. So this is a basic formula what you need. From this formula I will explain you one more alternative formula, that is Sn equals to n by 2. You can break this 2a as a plus n minus 1 into d. Now you can observe that this a plus n minus 1 into d can be written as an. So we got one more formula, Sn equals to n by 2 into a plus an. So why we need two formulas? One formula is enough, no? Why we need? We need when it is depending upon the given part. See here you can observe, here variables are n, a and d. So when n, a and d is given, so you can go with this formula. Here you can observe d is not here. So when n, a and an is given, then a nth term I don't have here, so I can go with this formula, Sn equals to n by 2 into a plus an. So alternatively you can write again in this way, you can replace an is nothing but what? Nth term. So this also sometimes we call it as L, that is last term. So it can be replaced by L. Sn equals to n by 2 into a plus L. I hope everyone understood the derivation of sum of n terms of AP. So in the next video, let me explain you how to use these formulas in a exercise 5.3. Thank you children.